When you want to sum up a sequence, you would use these two formulas. In this video, we're going to try and understand where these formulas comes from. So let's say you want to sum up from 1 to 100. Let's just give it a name, S100. So consider the exact same thing, but written in reverse order. So it would be 100 plus 99 plus 98 plus ... 2 plus 1. So consider in reverse order. So the trick now is to add these two together. So add the two equations together would give us 2 lots of S100 equals. Now we've got to add up all of these together. So this plus this would be 101. 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 So you've got 100 terms. So basically you've got 100 terms down here. So the quick way of doing this would be to get the first term. We'd get the first term. This is A1 here, and then add it to the last term. That's AN here. And then you've got 100 lots, which is n, the number of terms. You times it by n. So you can see where this formula comes from. That gives us, so summing up everything gives us 2 lots of S100, but we want just 1 lot of 100. So we would divide it by 2, divided by 2. So that's where this formula comes from, where A1 is your first term, AN is your very last one, and then N is the number of terms. So the same idea applies to this thing here. So let me give you a different sequence to show you where this formula comes from. So let's just consider this random one. Let's say you start out with 5 and then you add 3 each time, where 3 is your common difference. So 8, and then the next one would be add 3 would be 11, add another 3 would be 14, and so on. So you're trying to sum up everything here, where D is your common difference. So you sum up everything. So let me just rewrite this. So your first term, A1, and then your second term would be A1 plus your common difference, D. That's your second term. Your third term would be A1, and then you jump twice, 1, 2. So plus 2D. Your 1, 2, 3. Your fourth term would be, starting here, A1 plus 1, 2, 3 plus 3D. So this is your first term, second term, third term, fourth term, and so on, and it goes on. So if you want to sum up everything up to n, you would consider, the last term would be this. Let me just rewrite this. So the last term would be this, hang on. So it would be plus ... The last term would be A1, and then you jump 1 less. So that would be plus 1 less, n minus 1D. Because you notice here, your second term, you jump once. Your third term, you jump twice, 1, 2. It's always 1 less. It's always n minus 1. It's always 1 less. So this here is your very last term. So if you want to sum up everything here, consider the exact same thing but written in reverse order, just like earlier. Your last term would be this one here, A1 plus n minus 1D, and then plus all the others, and then the last one would be A1. The one before the last would be A1 plus D. So this is the one before last. This is the last one, and so on. So you write in reverse. So now sum up the two. So that would be 2SN. That would so to sum up everything, you would get this plus this. So A1, that's the first one, plus this one here, A1 plus n minus 1D. And then you times it by how many terms are there? 1, 2, 3, n terms. So you times it by n. So that will then give you this. So let me just rewrite this neatly. Let me just rewrite this. 2Sn would be n lots of this thing here. A1, the first one, and then this one here would be A1 plus n minus 1 d. So that's very similar to this thing here, very similar. So now now we only want Sn on its own, so divide everything by 2. So divide everything by 2. So that's this n over 2 here. That's this n over 2 here. So let me just rewrite this as n over 2. N over 2. So to understand where this comes from, look at this, A1 plus A1. That's 2 lots of A1. So that's 2 lots of A1. 2 lots of A1. So that's where the formula comes from. Okay, exact same thing here. Okay.